Packet Tracer 1044 is a comprehensive activity where you will build a switch and router network and configure layers 1 through 3 of the OSI model, starting with layer 1, the physical cabling. This is how the packet tracer will open. It will be 100% in physical mode. If you try to change to logical mode, it's not going to allow it. And there's 3 separate windows here that allow us to see the physical topology, the IP addressing information, and then the instructions. And you can adjust these windows as you like to make the view how you want it. Just to get started, the instructions start by telling us to, in part 1, set up the topology. So here we're going to be at layer 1, physical layer of the OSI model. And the first thing we'll do is we're provided with a rack, some cabling, and a shelf with some equipment. So the required router and switch are going to be moved from the shelf to the rack. We're going to be looking for the labels R1 and S1 as we decide which ones we're going to pull off the shelf. And if I hover over this top shelf here, I see these are multi-layer switches, but we are looking at a layer 2 only switch. Multi-layer switches are routers and switches all in one device. But here we have a layer 2 switch, and it tells us the name is S1. So that is the switch that we are going to be using. And below that, we have a router named R1, which matches our topology. We can grab the router, put the router in the rack, and I see my completion has gone up to 1%. So keep an eye on the completion. For most things, you should see it increase if you're doing it correctly. And then grab the switch S1 and just drop it in the rack. Next, move the required PCs from the shelf to the table. PCA and PCB, as we see we have them. Drop those right there on the table. Next, we need to cable the devices so they're connected to the network as shown in the topology. The first connection here, PCA, is going to be connected to S1. This would be a straight through copper Ethernet cable, and it needs to connect to F0/6 on the switch S1. Over on the pegboard, we can grab our copper straight through cable. Once you click on that, it'll allow you to zoom in if you need to without losing your selection. So we are looking for S1 F0/6. So they're numbered 1, 2, 3, 4, 5, 6. So if you click on that, it'll glow green there and let you know that you have selected it. And then go to PCA on the table here, and we're looking for that RJ45 jack that is labeled Fast Ethernet 0. That completes our first connection. We have another port on S1 that we are going to cable to router R1. Since these are dissimilar devices, by convention we would use, again, a straight through Ethernet cable, so we can grab another one of those. Fast Ethernet 0/5 is right above Fast Ethernet 0/6. And then the other end is going to go on router R1, Gigabit Ethernet 001. 000 is on the bottom, so it would be the upper port there. One more connection for the network connections. We'll still be doing some console connections. That would be router R1 to PCB. Now, conventionally, routers and PCs are both considered similar devices where you would use a crossover Ethernet cable. This is less significant in modern times because modern devices have something called MDIX that compensates for that and allows you to use either. So I believe that the grading will give you credit for either type that you use. I'll go ahead and select the crossover. This is going to go to the other gigabit Ethernet port on the router here. You might have to just zoom in a little bit to be able to get that port. The green box there is showing that it has accepted the connection, and then going down to PCB, connect to the other end of that cable so that that PC will have a network connection. That completes all of the network connections. The other thing that we'll need to do, because we won't have access to the config tab on these two intermediary devices, the switch and the router, we will need to have a console connection to go through the terminal emulator on the PCs. PCA will be the console access for S1. What we want to do, this light blue cable is a console cable. We're looking for, on S1, the console port, which is not on the front. We have to right-click, inspect rear, and there is the console connection. Can just close that back out when we're done with it. And the other end of that is going to go on PCA RS232. The console connections I don't believe are graded, so don't worry if you don't see the percentage go up. The other console connection will be from PCB RS232 port. And for router R1, we will see the console port on the front. If you hover over, it's going to verify when you do hit that port. So now we have our two console connections. We're completely done with our cabling. Finally, in part 1D, power on the devices, right? Here's the power switch for the router. So you just click on that, you'll see a green light indicator come on. Switches do not have typically power switches inspecting the back of the device. It's just a power cable. You do need to turn the PCs on. There's a button there, is the power button. Again, look for that green light indicator to come on for both of the PCs. By the way, feel free to save your packet tracer. It's good to save it periodically. Now that part 1 is done, on PCA we're going to configure the IP address, subnet mask, and default gateway settings. Access PCA by just simply clicking on it, going to the desktop and the IP configuration. Please keep in mind we've got not only IP4 but IP6 addressing to do, IP version 6. So here again we're working at layer 3 of the OSI model. If you like, you can just copy the IP address portion and paste that in. Remember, don't put the /24 here. That corresponds to the subnet mask, which when you click on that field, it will pre-populate it for you, and just by chance, it is correct. That is a /24 equivalent for the subnet mask. For your default gateway then, put that in as well, and now we can move on to the IP6 address. For the IP6 address, don't copy the /64 in there. That'll go in a separate area. And the /64, there's the slash, and then the 64 goes on the other side of that. Make sure you remember that so you get your grading. The link local address, there is none, but its default gateway for IP6 is the link local address of router R1, which we'll get to in a little bit. So make sure that you do paste that into the correct area, the default gateway field, and not the link local address for the PCs. Moving on to PCB, just do the same thing. Make sure you're following the table. The IP address for PCB is 192.168.0.3. Again, that is the equivalent of a /24, so there's no change there. And the default gateway for PCB is on a different network. It's on the 192.168.0 network. Then the IP6 address for PCB up to the /64. That is the globally routable IP6 address, and that is a /64. Which is pretty common prefix length for IP6 endpoints. The default gateway is the link local address of the router, so that goes in the default gateway field. Note there's 2 colons there. That means that it's shorthand for a lot of consecutive zeros, so it takes up less space to put 2 colons there. That puts the percentage rate at 43%. From a command prompt window on PCA, ping PCB. Command prompt PCB is 192.168.0.3. And the question is, why were the pings not successful? looking at your document, that's the first question there. It's timing out because we have not set up the router to act as a default gateway yet. So there's no way for layer 3 traffic to be routed, but we're going to fix that. In step 2, we're going to configure the router having a console connection through PCB. Go to PCB, click on terminal, accept the default settings, access the command line. This is at factory default settings. So it's going to ask, would you like to enter the initial configuration dialog, which is menu driven, where it asks you questions to set everything up. Just say no to that so that you can get the command prompt. We've consoled into the router. We can use the enable command, or EN for short. Enter configuration mode. Assign the device name to the router. Host name, set system's network name. Host name R1. Immediately our prompt changes. Moving on to D, assign class as the privileged exec encrypted password. When it says encrypted, so we have to use the enable secret command. Otherwise it would be in plain text. And we are assigning CLASS as the password. And now let's go ahead and set up our console line with a password. To get to the console, we go into line configuration mode where we have our VTYs and so on. What line are we working on? The console, and we have to put console 0. We can assign Cisco as the password by using the very intuitive command password. And then if you do a question mark at this point, we have to remember our login command hand in hand with our password to enable password checking, or else that password won't do any good. So we simply put the command login there. We always have our check results button that we can click on to see our progress, and then I can close that. Back to our list of things to do. The next thing is to assign Cisco as the VTY password and enable login. I don't have to exit, I can just simply put line VTY 0 space 15. We're repeating what we did on the console, so a quick way is just to up arrow, password Cisco command to save some typing, and then up arrow the login command. Moving on to step G, encrypt the plain text passwords. Go exit to global config. The service that we're going to use for this is, remember your question marks that you can use for help or hints. This is going to be service password encryption to encrypt those plain text passwords. This will apply to both current and future passwords that are configured on the device. The next thing is the banner message of the day that's going to warn anyone accessing the device that unauthorized access is prohibited. The message of the day banner that they will see at the console access level. For the message itself, you can use any kind of delimiter to tell it where the message begins or ends, except for any character that appears in the message. I'll randomly pick the hashtag symbol and just put in a message of your choice, something to this effect. Once that's done, and by the way, make sure you have a beginning and an ending delimiter that match and do not appear anywhere in the message. So in other words, I could not have used the exclamation point as a delimiter. The next thing is to configure and activate both interfaces on the router. If I want to do a show IP interface brief, but I don't want to have to exit back and forth between config mode and privileged exec, I can just insert the word do in front of a command such as show IP interface brief without exiting config mode. So the two interfaces that we'll be configuring are shown on our topology. We're just going to configure the 2 gigabit Ethernet interfaces that are in use in this scenario. And we see that they're administratively disabled, so we will also need to enable them. We will be configuring them with both IP4 and IP6 addresses. To begin with, looking at interface G0/0/0, to go into interface mode, I've got my -IF indicating I'm in interface configuration mode. To put the IP4 address on, IP version 4, We see it's 192.168.0.1, and we must have the mask on there. A /24 is equivalent to 255.255.255.0. I see my percentage has gone up. Then I must put the IP6 address on there as well, which is simply IPv6 and then address. And for that one, you actually can leave the /64 on there because that's the kind of notation that IP6 addresses use. They don't use dotted decimal masks because this is hexadecimal notation here. Again, my percentage has gone up. That is my globally routable GUA global unicast IP6 address, which is routable on the internet and so forth. We also have a second type of IP6 address we're going to configure on this interface, which is called a link local address, local only to this link. It does not get routed outside of that. We just simply use the IPv6 address command again, but this time with the link local address. And there's one more piece we have to add. We have to add the link-local. And by the way, you can always tell a link local IP6 address because it'll always begin with FE80 hexadecimal. So that takes care of the 3 addresses that we need to put on this link. And we also need to enable it so that traffic can be passed through it by doing the no shutdown command or no shut. Do show IP interface brief again to see the IP version for information, and I can add show IPv6 interface brief to see the IP6 information as well. That leaves gig 001 to do next. I do not need to exit at this point. I can just change to that interface by typing in the interface name G001. Up arrow to use the previous commands, but just change this one to 192.168.1.1, same subnet mask. For the IP6 address, I will recall the previous one, and the only change :1 being added. So it's ACAD :1::1. Again, this is shorthand for a series of zeros. IP6 FE80. This is the same. I can have the same link local address on every link on my router as long as that address is unique on that link itself, that the other end doesn't have the same address. So it's perfectly legal for this router to have the same link local IP6 address on multiple interfaces. And these are the IP6 default gateway addresses that the clients are using. That last part is, again, no shut. Go ahead and enable this interface. And now if I do my show IP address or show IP interface brief, both interfaces are addressed and up at both IP4 and IP6. In step J, configure an interface description for each interface indicating which device is connected to it so that anyone on the device can easily see which interface is connected to what in case they don't have the diagram handy. So I'm currently working with G001. I'll just stay on that interface and add my description. You could say connected or connection to, we could say S1F05. So just something helpful. It doesn't have to be exactly the same as mine. And then over on interface G000, I can just up arrow and say connection to host PC-B. In step K, to enable IPv6 routing on this router, we are going to add the command IPv6 unicast-routing to enable IPv6 packets to be routed through this router. In step L, it's time to save our running configuration to the startup configuration file, because right now all these commands are in volatile RAM, but they're not in the persistent non-volatile RAM or NVRAM that gets called into play when the device boots up. So if we were to do a show star or show startup config, we see startup config is not present because we've done a lot of configuration, but we haven't yet permanently saved it. It's still just temporary until the next reboot. If you do the dir command on a router, it'll show you what's in the flash that's built in, or there might be external flash being used. This is where you would find your operating system file that ends in .bin. But this isn't where our startup config lives. We could do a dir nvram on the other hand, and that's where it would be, but there's no files there yet. We can change that by doing a copy run or running config to star or startup config, just to accept the default file name. We now, if we up arrow and look at our NVRAM, we now have that file located in non-volatile memory, where it will boot from that file. Finally, it wants us to set the clock on the router. If we say show clock, it's currently set to that default date, March 1st, 1993. To set the clock, it's pretty self-explanatory, and you can guide your way through it with the question marks. We say clock set question mark, what's the current time? Whatever your current time is, hours, minutes, and seconds, space question mark, what day of the month is it, whatever day it is, what's the month? 3-letter month abbreviation is fine. And then finally the year, and then CR for carriage return. I don't think that one will affect your completion percentage, so don't worry if you don't see your completion percentage go up. Next, from a command prompt now, ping PCB from PCA. I'll just up arrow to do that from before. That first request timed out because of the ARP request. PCA does have the ARP entry in its table for its default gateway. That's the MAC address of this interface on R1. Next question in your document. Were the pings successful? Yes. Explain. Because we configured the router and enabled IP and all the interfaces on the router so that the router is now routing traffic across the 2 subnets. Moving on to step 3, configure the switch. PCA will be our console connection for the switch using the terminal application to access the console. Enable mode is what we need. Conf T, hostname, S1 is the hostname. Configure and activate the VLAN interface on the switch S1, which do show IP interface brief shows me that it is unassigned and administratively down. So we'll need to do the IP address command and the no-shut on interface VLAN 1. Our IP address for S1 is 192.168.1.2 with a mask of 255 times 3.0. Don't forget to do the no-shut to enable that interface. And then I do show IP interface brief now shows that it is configured with that IP address and it's up and reachable now at layer 3. The next thing we must do, however, is just like the PCs, that switch needs a default gateway in order to reach or be reachable from other networks. And the default gateway, of course, is router 1, same as for PCA. Exit out of interface mode back to global configuration mode. The command is IP default-gateway, and then the IP address of S1's default gateway, which is G001 on router R1's address, 192.168.1.1. Now we can go on to the last piece here, which is save the running config to the startup configuration file. For that, we exit. You can hit exit or end, doesn't matter. And we have to do our copy run star, copy running config to startup config. At this point, you should be at 100% completion, and go ahead and save that packet tracer file. If it's not 100%, go over to your check results, assessment items, look for red X's, and that will give you some great clues on what to go back and fix or double check. There's still a little left to do in the document. Going now into step 4. We want to be able, we know we can ping from PCA to PCB, but we also want to be able to ping from S1 to PCB. So remember, S1, we use PCA for that, and we say ping, what is PCB's address? 192.168.0.3. And that is successful. Next, we're going to use some show commands just to take a look at some more layer 3 stuff and routing. Turning to the document, the questions, what we're looking at is the show IP route command on R1. PCB is our console connection. Show IP route will show us the routing table that's in the memory of R1, what routes it knows about. What code is used in the routing table to indicate a directly connected network? You can look at your key up here and see that the letter C indicates connected. And that is analogous to the 2 interfaces that are connected to other devices, which is the answer to the next question, how many route entries are coded with a C? It's equal to the number of interfaces that we IP addressed and brought up. Because whenever you IP address an interface on a router and bring it up, and once it's all the way up, it automatically will create a pair of routes in the routing table. One is the network that interface, that route represents, and the other will be the actual host address of the interface. So there are 2 C routes, and what interface types are associated to the C routes? Well, in this case, they're both gigabit Ethernet interface types. Next, do the same thing, but with a look at the IPv6 routes now that we've enabled IP6 routing. And we do see the same number of connected routes, it's just we see the IP6 routes in the hexadecimal notation. In step 2, we're going to look at a specific interface, show interface G0/0/1 on R1. What is the operational status? That you can find right there. And if you want to just copy that line right there and just paste it right in your document, that's fine. What is the media access control address? That would be the full address. Again, you could just copy that part right there and paste it into your document. In this case, the BIA is the same. And how is the internet address displayed in this command? Here you want to look for your IP address, right? Your layer 3, in this case, your IP4 address. This is the information that you could put in your document. And if you wanted to see the equivalent, you would just add IP, like with the routing and things, you would just say IPv6 in front of that. And that would give you your IPv6 information. But you don't need to put that in the document. In step 3, show IP interface brief, which we already looked at. To get a summary, if you go over to S1 and do the same thing, you'll get some indications that are more related to all of those layer 2 ports and your virtual, your software interface. And finally, a couple of questions. If the G001 interface showed that it was administratively down, what interface configuration command would you use to bring the interface up? No shut, right? And what would happen if you had incorrectly configured G001 on the router with an IP address of 192.168.1.2 instead of 1.1? That would have had the same address as S1, for one thing. But another thing is that all of the devices have been configured with 1.1 as their default gateway. So they wouldn't be able to reach any other networks, would they? If their default gateway had the wrong address, it wouldn't be able to function as the default gateway, and therefore PCA would not be able to ping PCB. That wraps up this packet tracer. Thank you.